All right, right now we're taking a look at the second rule that we have in section 3.2. I am in our 3.2 notes on page 6. This is the quotient rule. This also needs to be known for your exam, so we need to know this. And this is the derivative of f and g are differentiable functions, and the derivative of the quotient is also differentiable for x such that the denominator does not equal 0. So taking the derivative of a function where you have something divided by another value, another function, is going to be g of x times f prime of x minus f of x times g prime of x all over g of x squared. So for me, I remember it this way, and this is how I was taught, is that it's low d high minus high d low all over low squared. You can also look up a bunch of different YouTube videos on different ways to remember this. They have a lot of different songs and different things on those lines. And again, this little note down here that you cannot distribute a little prime saying you can distribute a derivative. It's not, it's an operation. Okay, so looking at the examples on the next page, there is again a proof here to go ahead and look at on your own and fill in this first step. First one that we're going to go ahead and look at is on page 7. And it says to find the derivative of x minus 1 all over 2x squared plus 3. So saying the derivative of this, and again, I'll set this equal to y. So y prime is equal to, and this starts off with the bottom, so low. And I'm just going to go ahead and take our derivative and rewrite it as 2x, or not our derivative, our denominator, 2x squared plus 3x. So the denominator times the derivative of the top, the derivative of the numerator is just 1, minus the top times the derivative of the bottom. And the derivative of the bottom, or the denominator, is going to be 4x. And then this whole entire thing is over the denominator squared. Okay, now we do not leave our answers like this. We need to clean this up. So I'm going to go ahead and distribute through the 4x and the negative, and this one luckily is just a 1. So rewriting this, we have 2x squared plus 3. This is going to become 4x squared, and it's going to become negative, so negative 4x squared. This is now going to be a positive, and 4x times 1 is just plus 4x. All over 2x squared plus 3 squared. And then we can combine our like terms up here. And we have 2x squared minus 4x, which is negative 2x squared, plus 4x plus 3, all over 2x squared plus 3, quantity squared. And I want you guys to notice the numerator cannot be simplified at all. We cannot factor this. A lot of times in these cases you can factor the numerator and continue to simplify this expression. But for this one, this is as far as we can go. So I'll just go ahead and box this, and this is our derivative, again using that quotient rule. So down below this, there is another problem that's a little bit more complex. So this one says, take the derivative of 3x minus 1 divided by x times e to the x. So if you notice, we have a quotient rule and a product rule in the same problem. So let's go ahead and give this one a try. Again, I'm going to go ahead and set this equal to y. And I'll say dy dx. And again, any notation to explain that you are actually starting the derivative needs to be written there. So f prime, if you want to set it equal to f, y prime, something along those lines. So this is going to be low, so the denominator, times the derivative of the numerator, which is just 3, minus the numerator, the top, times the derivative of the bottom. Well, the derivative of the bottom is a little bit more complex than the last one. This is going to require us to use the product rule, which was in the previous video. So this is going to be the first thing times the derivative of the second. The derivative of the second is just e to the x, plus the second times the derivative of the first, which is just derivative of x is 1. Then this is all over the denominator squared. And again, this is using the quotient rule. So from here, again, we need to clean this up. We need to multiply this all out and FOIL it and combine like terms. So from here, we have 3x e to the x. Simplifying this and multiplying this out and distributing the negative, we should have negative 3x squared e to the x minus 3x e to the x plus x e to the x plus e to the x. And then this is still all over, all divided by x e to the x squared. So if you notice in here we have a 3x e to the x, and those will reduce down. And then combining this, doesn't look like we combine any terms, but definitely can factor out an e to the x, so I will just go ahead and do that. So factor out e to the x, I'm left over with a negative 3x squared plus x plus 1. And again, this is all over. And I'm going to kind of rewrite this because if you notice there's an e to the x in the denominator and one in the numerator. So this is the same as x squared e to the 2x. And so one of these e to the x's can reduce out. So I'll go ahead and cancel out one of those. And then therefore this is going to simplify to negative 3x squared plus x plus 1 all over x squared e to the x. And again, remember we simplified this. This is not going to factor, so we cannot go any farther with this to see if anything else would reduce down. This is as far as we have, and this is the derivative. Again, this is a good example because it's using both the quotient rule and the product rule. So you get some really good testing capabilities here to see if you understand both of those formulas in just one problem. There's still some additional exercises for you guys to practice on your own, and then check my notes to see if you understand them and if you got them correctly. Make sure you try those on your own, and then let me know if you have any questions.